Okay, YouTube, in our last video, we looked at what an angle in standard position is, and we specifically measured it using units that we call degrees. And so this is something, of course, we're very familiar with. When we sketch angles in standard position, we're just agreeing that the initial side is on the positive x-axis, and then it's either rotating clockwise or counterclockwise some number of degrees. In this video, what we're going to do is introduce the notion of measuring an angle using a different type of measurement that we refer to as a radian. Okay, and it is related to the radius of a circle, but let's go ahead and kind of distinguish between these. We say that a radius is a measurement from the center to the outside of the circle, the focus of the circle to the perimeter of the circle. Whereas when we talk about a radian is a measurement, a measure of rotation. And so specifically what we're going to do is we're going to start with the definition of what 1 radian's worth of rotation is. And so we say down here on figure 5.6, what is 1 radian? We say, well, 1 radian is this. We have to have some central angle in a circle. And when we refer to a central angle, we're referring to some angle that starts in the middle of the circle and proceeds to the outside. But when you have some central angle, what I'm going to do is I'm going to refer to this as this angle theta. Essentially what happens is it goes out and it intercepts an arc. And so we're going to give this a name. We say that this is the intercepted arc. The fabulous thing here is this. When you measure an angle, we could certainly use these degree things that we impose on this, but another way to kind of measure this is to kind of ask the question, how many times does the radius length of the circle, which doesn't change no matter where you go, how many times does it fit into this outside arc length? Because what I know is the bigger and bigger this angle gets, then the bigger and bigger this outside arc length would get, and the radius would fit in even more times. And so when we define a radian, at least 1 radian, we say it is the amount of rotation that you must spin if you are some central angle on a circle, such that the radius length is equal to the intercepted arc length. This is 1 radian. And so to kind of go back and read this, what this says here, it says 1 radian is simply the measure of a central angle, so it's amount of rotation of a circle that intercepts an arc equal in length to the radius of the circle. So the fabulous thing is, no matter what size circle you have, I could make an itty bitty circle, so smaller than this one right here. If you were to look at this angle right here, we say that this is, some angle theta, maybe it's 1 radian. Basically what I can tell you is that this distance r does indeed fit into this arc length r around the outside. So this is kind of like 1 radian. The thing here is we can build up this definition to kind of include angles that are bigger and bigger. So that is to say that if this radius length fits into the intercepted arc length 1 time, then this angle is 1 radian worth of measurement. So when we look at up here, what would 2 or 3 radian angles look like? What you're going to see is this. We have 2 other angles here. We have beta, which is 2 radians, and gamma, which is 3 radians. But what you're going to notice here is that I have an angle that is 2 radians if and only if this is true. We say that the intercepted arc around the outside, you can see this right here, the radius length here of the circle fits into the outside arc twice. And so since that's the case, we would say that this is 2 radians, which basically indicates that you rotated far enough that the radius length would fit into the outside twice. And likewise, if it were to fit in not once, not twice, but thrice around the outside, then this angle here, gamma, we would just say is 3 radians because the radius length of the circle fit into the outside arc length, intercepted arc there 3 times. And so in general, what we could say is that the radian measure of any central angle is the length of the intercepted arc divided by the circle's radius. Or in other words, an angle in radians, angle is as big as the number of times that the circle's radius fits into the intercepted arc length. So we'd say the circle's radius fits into the intercepted arc length. And so that's what we're referring to as radians, really just saying how many times would the radius fit into the arc length. That's how many radians big this angle is. And so let's go ahead and define formally what we mean by radian measurement. So this angle theta here, you'll notice that we have a circle with a central angle theta that starts over where we might consider this to be like a positive x-axis, so kind of in standard position, and rotating counterclockwise, but the radius of the circle is consistently the same distance no matter where you go in the circle. And so in order to find out how many radians this angle is, we're going to answer the question, how many times does the radius length fit into the intercepted arc length? And we're going to use S to indicate the arc length. So we say S is the arc length. And that is the letter that we, I'd say, pretty consistently use to indicate the arc length of a circle. And so if we want to answer how many times the radius fits into the arc length, then really what we're saying is then this angle in radians is equal to the arc length divided by the radius, which would tell you how many times the radius goes into the arc length. And so let's go ahead and take a look at how this might look in general practice in terms of how we might measure an angle other than in degrees. So taking a look at this situation here, you'll notice that we have this angle theta. And so it seems that the radius of this circle it appears to be 6 inches. So I'm going to write that down. 6 inches is the radius of this circle. I also know that the arc length is 15 total inches. And so if we want to measure this thing in radians, then according to our definition, all we need to do is take the radius length and see how many times it fits into the arc length. So I'm actually going to write this out here. I'm going to say, well, the arc length is 15 inches and the radius is 6 inches. And I'm going to point something out immediately, that these units of distance, since we're always taking a distance, which is the arc length, divided by the distance, which is the radius, the distance units are going to cancel out. And so what we find out is when you measure things in radians, we say radians don't need to be labeled. Don't need to be labeled. So that is to say that when we write, say, theta equals 2 degrees, we had to label this, and this is most certainly degrees. But if we were to write something like, hey, theta equals 2, we assume it's in radians. It's in radians. And the reason why we assume this is because it's not in degrees. It's a real number. So we say radian measurements are unitless. And furthermore, 6 and 5 here, if we reduce these here, 6 and 15 rather, 3 is a factor of each. So we say 3 goes into 15 5 times, 3 goes into 6 twice. So what we end up with is this, with 2.5, and I'm going to label this 2.5 radians. I'm going to label it 2.5 rad. And I'm also going to label it 2.5 because any of these answers are going to mean the same thing. And all this really simply says is that, hey, this 6 right here, this radius length of 6 fits in one time, that'd be 6, and then another time, that'd be like another 6, so for 12, and then a half a time for 3. And that's what we're basically answering here. So let's try this again where we don't have an image, but we say a central angle theta in a circle of radius 12 feet intercepts an arc length of 42 feet. So what is the radian measurement of theta? So I would recommend always drawing a picture, and I'm going to start with just the radius length here. And this radius we've learned is 12 feet in length. And so what we have is some arc length around the outside, and what I'm going to do is I'm just going to kind of extend this a little bit here. I say maybe over to here. I can kind of imagine that my central angle, and we're going to call this theta here, intercepts an arc length of 42 feet. And so if I really want to answer how many radians this is, all we're just going to say is that I get 42 feet, which is my arc length, divided by my 12 feet. The units cancel out immediately. It looks like we would get 21 over 6 if we cut these both in half. Looks like 3 is a factor of both of those, so we'd say 7 over 2. And so we really get 3.5, and I'm going to write 3.5 radians is the measurement of this angle. So this is what we mean by radian measurement. As we go forward, we're going to look at how we convert from degrees to radians to degrees. Cheers.